Alrighty, the lesson for homework: help classify each triangle as acute, equal angular, obtuse, or right, and make sure that you explain your reasoning. Okay, so number 4, triangle ABD. So here is A, B, D, close it, and then you're gonna go ahead and tell me what type of triangle that is. And then here is triangle B, D, C, and that's number 5. Number 6 would be A, B, C, close it, and I would recommend that you take a look at these 2 angles as it's part of this angle here for that triangle. If point K is the midpoint of segment FH, classify each triangle in the figure at the right as equilateral, isosceles, or scalene. So this is our given, and K is over here. So that means that since K is the midpoint of segment FH, that means that this midpoint splits the segment into 2 congruent parts. But we know that this here is 2.5, so that means that this segment is 2.5. But if we take a closer look at this particular triangle, notice that this segment is 5 units long. So that means with this tick mark being here and this tick mark being here, this segment has to be 5 units long. But notice that this segment here is 2.5 and 2.5 all together. So I'm going to go ahead and draw my tick marks to show that all of these sides are congruent. So if I look at triangle FGH, close it, well, what type of triangle is that? Number 10, G, J, L, close it. I would recommend that you draw or redraw the triangle. So I have G, J, L, and I'm going to go ahead and draw a point here because as you can see, this right here is 5 units long. And then we can see that this segment here is 3 units long. Don't forget the 8 there, and don't forget the 5 there. So you can go ahead and tell me what type of triangle that is. Okay. Then you can go ahead and figure out what FHL is. Find X and the measures of the unknown sides of each triangle. Okay, I can see that this here is an isosceles triangle. So that means I need to look at these 2 tick marks here because this and this are congruent, and it has at least 2 congruent sides, so therefore this is an isosceles triangle. So what do I do with this and this being congruent? I set them equal to each other. And I solve for X. So X is equal to 11, and now I need to figure out what MN is. So I do 2 times 11 plus 7, which is 22 plus 7, or 29. So that has to be 29. But I need to figure out what LN is. But notice that this and this are congruent. And if this is 29, then this has to be 29. So those are your answers. Number 13. Take a look at the tick marks and then work your way through the blanks. Notice that this is actually an equilateral triangle. Okay. Let's go ahead and... So right here it says classify each triangle as acute, equal, angle, obtuse. Alright. This triangle is using this figure, and these two things are using this figure. And then here, if point C is the midpoint of segment BD and point E is the midpoint of segment DF, this is pretty important that you read this stuff. Well, if C is the midpoint, here's C. What does it do to BD? And then point E is the midpoint of DF. Here's point E, and this is DF. Well, what does point E do to DF? Okay. Then your goal here is to classify each triangle as equilateral, isosceles, or scalene. Okay. Equilateral means that all sides are congruent. Isosceles means at least two sides are congruent, and scalene means no sides are congruent. 36. Algebra. Find x and the length of each side if triangle ABC is an isosceles triangle, where segment AB is congruent to segment BC. So I recommend that you mark your picture with the tick marks. Then do the algebra. Okay, so measure angle 2. Find each measure, measure angle 2. This is what you call an exterior angle, and these two things are what you call the remote interior angles. So you're going to use the exterior angle theorem. And the exterior angle is basically the exterior angle the exterior angle is equal to the remote interior angles added. Okay, so here's your exterior angle, that's 112, is equal to this and this together. So that's 32 degrees. And this number is not 2 degrees, right? This is 32 degrees. It has the degree symbol here, but this one doesn't. In fact, this is what we call angle 2. So if I'm talking about angle 2, I want to find the measure of that. So I write plus measure angle 2. And what is my goal here? I need to solve for the measure angle 2. So minus the 32, minus the 32. So do your algebra. So what is the measure angle 2? What is the measure angle 2 equal to? Okay, use your calculator to figure all that out. Okay. All right, you're gonna go ahead and do the same thing, because now you're looking for the measure angle MPQ. So how long is this angle here? Well, this is your exterior angle, and then these two things are your remote interior angles. Okay, so then you're just gonna go ahead and use this idea to figure that out. Okay. So here you have a triangle consists of two triangles, and then you have just two triangles stuck together, and your goal here is to figure out how long these angles are. So you need to understand the triangle sum theorem, which means that all the angles in a triangle add up to 180 degrees, right? So this angle plus this angle plus this angle has to equal 180. This angle plus this angle and this angle add up to 180. If I were to take a look at this triangle here, this has to be 90 degrees, right? This square implies that this is 90 degrees. So in order for me to figure out what the measure angle 1 is, I need to do 180. I need to do 180 minus 90 minus 29, and whatever that is the measure angle 1, okay? And then over here, this forms a linear pair, and a linear pair adds up to 180. So I have part of 29, and then whatever is left of that 180 is the measure angle 2. And once you find the measure angle 2, you have 17 degrees here, right? So then you're going to go ahead and do 180 minus whatever this is, minus 17, which will give you that measure angle 3. And then you're going to go ahead and then figure this out. And note that you're just going to have to think this through, because look, again, all the angles here add up to 180 degrees. Note the fact that this here and this here are congruent, right? So you need to do 180 minus 105, right? And whatever that is, you need to divide that by 2, because that's going to give you these two things here. Okay, so whatever the answer is, you put here and also here. And then the measure angle 3, finding that should be very, very straightforward. Okay, you should be able to do these problems. Okay, and remember that 90, this right angle indicates 90 degrees. And then over here, this one's a little confusing because it has algebra stuff. But it doesn't change the fact, or the formula doesn't change whatsoever, or the theorem itself doesn't change whatsoever. You still have your exterior angle, and then these two things are your remote interior angles. So you should have 100 equals 2x minus 1 plus 2x plus 27. Solve for x, and then figure out what JKL is, okay? It says find each measure. That means you're trying to, what you need to do in this case is, here is JKL, so it's implying that we're looking at this angle. Once you solve for x, make sure that you plug it in, and you'll get the answer. And then find the value of x, then find the measure of each angle. You need to use the triangle sum theorem. You need to add all these angles up equal to 180 and then plug them in. Okay, once you find x, you need to make sure that you plug them in. And over here, that's the same idea, except you're not using the triangle sum theorem. You're using the exterior angle theorem, where this is equal to these two things combined. Plug it in once you solve for x, and then you should be fine. Classify the triangle shown by its angle. So you need to tell me whether this triangle is acute, obtuse, right, and is that all? I think, is that all that I have? Let me check with the 4-3 notes real fast, or 4-4 notes. Nope, that's not it. You need to tell me if it's acute, equal angular, obtuse, or right angle. Okay, so that means that you take these three things, add them up equal to 180, plug them in, and then based on one of the angles or whatever, you need to tell me what type of triangle, if it's right, acute, obtuse, or equal angular. And then you're going to go ahead and list the angles and sides of each triangle in order from smallest to largest. So if I were to take a look at number 14, so here is 90 degrees, right? The side opposite to that, right, the angle and the side do relate to each other. And I say this all the time, the bigger the angle, the bigger the side. The smaller the angle, the smaller the side, right? So let's go ahead and list the angles and sides of each triangle in order from smallest to largest. Okay. So this right here, no doubt about it, this is going to be my bigger side. This right here is my smallest side, right? That means that angle W is my smallest angle. And then angle Y is my second smallest angle. And since this is a right angle, right, this is what I call the hypotenuse, and the hypotenuse is always the longest side of a right triangle. So it has to be angle Z. Okay? So now, let's go ahead and rank the sides from smallest to largest. So then, since angle W is the smallest angle, then YZ has to be the smallest side. And then, since angle Y is my second smallest angle, that implies that WZ, segment WZ, okay, so this is segment YZ, and segment WZ must be my second smallest side. And then lastly, since angle Z is my largest angle, we can totally say that WZ is my, or not WZ, WY is my longest side. And that's my answer. Okay? So remember to refer back to your notes so you can answer these questions here. And this one right here is a little challenging. Not really, because you're trying to solve for x. It looks like you have the expressions and such inside the angle. So you're going to use the triangle sum theorem, plug them in, and then list the angles and sides of each triangle in order from smallest to largest. Okay? And then you will use the figure to determine which side is longer.